All right, so today we're working on pages 212 to 215. So we're just doing review today. And let's look at number 13. It says Justin drove at a steady speed of 60 miles an hour. Write an equation to represent the relationship between the total distance Justin drove, d, in a certain amount of time, t. Which value is the dependent variable? Which one is the independent variable? Explain. So let's write our problem. So the total distance is d. So we want something to equal d. And 60 miles an hour times t, which is the time he drove. So there's our equation. So that's the first thing we did. Then we have dependent and then independent. So which one is the dependent variable? Which of these numbers depends on the other to find the solution? That would be the distance traveled, total distance. That would be our dependent variable. Total distance, d. Our independent variable would be t, the time. How much time was spent driving? That's the independent variable. And then how do I know that? The distance is going to... Time is going to determine the distance. I have to know time to know distance. All right. Number 14, Mary and Will rent tandem bikes for $10 an hour. Which variable is the dependent variable? Which is the independent variable? Write an equation to represent the relationship between the number of hours and the total cost. So equals cost. So let's do C and H. Total hours. $10 an hour. So 10 times what? H. 10 times the number of hours. Which one of these depends on the other? Total is the dependent. Hours is the independent, because the cost depends on how many hours they do it, or they ride the bikes. Okay. Which ordered pair is not included in a graph of 2x plus 5 equals y? And remember, I prefer to have my y on this side. Same difference, does not matter. Which one would not be included in that graph? Well, we don't know all the numbers yet, but because we have the plus 5 here, even if x was 0, you're going to add 5 to it. So A would be the one that is not included. And it says David chose A as a correct answer. He actually got it right. How did he get that answer? So he did what we did. He replaced x with 0. And then, so we'll do 2 times 0 plus 5 equals 5. So we know that that could not be an answer. All right, we're already moving on to the next page. Got all sorts of books everywhere. Okay, so here we have a table and we need to fill in the table. So 2 is 17, 6 is blank, 10 is 65. We have to figure out what numbers go in all of these blanks. So Mr. Wise is ordering a set of books for his class. Each book cost $6. There is a flat shipping fee of $5. The table below shows the relationship between the cost and the number of books. Fill in the blanks to complete the table. So 2 books is $12, but then we have to do plus 5, and then they get 17. So this is something plus 5. So what could I do? Let's do number 6. So 6 plus 5, and each book is $6. So 6 times 6 is 36. 36 plus 5 is 41. So we at least have those. So this other part is going to be a little more difficult. So what I'm going to do is I'm going to do 29 minus 5, which is 24. Now I'm going to see how many times 6 goes into 24. And that is what? 6 goes into 24 4 times. So we can double check. 4 times 6 is 24. 24 plus 5 is 29. All right, so for this one, and I'm going to, be honest, it's between 6 and 10. So it's either going to be 7, 8, or 9. So for this one, we're doing 53 minus 5. I can't do 3 minus 5, so I have to borrow. So 4, carry the 1. 13 minus 5 is 8. Bring down the 4. So how many times can 6 go into 4? So this is now the total cost of books. So I need to divide 48 divided by 6, which is 8. So let's try it. 8 times 6, the number of books, is 48. 48 plus 5 is 53. All right, number 2. Based on the information in problem 1, choose true or false for each statement. The total cost of 11 books is $77. Well, we could do 11 times 6 is what? 66. 66 plus 5, because we have to have that flat shipping rate. Is it 77? It is not, so that is false. Total cost of 7 books. We have 7 times 6, which is what? 42. 42 plus 5 is 47, so that one's true. Mr. Wise spent $137 on books. He bought 22 books. So we're going to divide, or first we subtract 5, because that's our flat shipping rate, and we have 132. I'm going to do the work. Can you see it over there? Yeah, 132. I'm going to divide that by 6. 6 goes into 13 2 times. 2 times 6 is 12. Bring the 1 down. 6 goes into 12 2 times. 22. So yes, that one is true. If Mr. Wise buys only 1 book, he pays $6. Is that true? It is not true. He still has to pay that $5 shipping fee. To find the cost of 20 books, multiply 65 by 2. I don't even know where he got 65 here. We would do 20 times 6 plus 5. So that is false. All right. Number 3, on a road map, 1 inch represents 2.25 miles. Which statement or graph correctly represents this relationship? Circle all that apply. So 1 inch to 2.25. So here, total miles equals 2.25 times I. That actually works, because if I had 2 inches, then I would multiply both by 2, and then I would find that. So that is correct. The ratio of inches to miles is 4 to 9. So if I did 1 times 4, that's 4. And if I did 4 times 2.5, that would be 9. So that would be correct. I equals 2.5 m is not correct because that's the opposite of this. So we know that one's not true. D, the ratio of inches to miles is 9 to 4. That's not true because if it's 4 to 9 here, it's not 9 to 4 there. So that one's not true. And then here we look, we have inches, miles, but then here we have miles, inches. Inches would be on the bottom, miles would be on the side, so it is E. All right, number 4. With a family bowling pass, families can bowl for $4 a game. The pass costs $10 per year. Use an equation, a table, and a graph to explain the relationship between the total amount of money spent on bowling in a year, A, and the number of games in a year. So part A, it wants us to use words in an equation to represent the problem. So we're going to say total spent amount per game, number of games, and cost of pass. So let's go ahead and fill these things in, and it's going to help us. So the total amount spent is A. Amount of money per game is 4. The number of games we don't know is G, and we're going to multiply 4 times G. And the cost of the pass is plus $10. So this is our new equation. So let's make a table for it. 3 sections. So number of games, because this is our independent variable. Number of games, and we'll do 1, 2, 3, 4. And then here's our equation, 4G plus 10. And then amount spent, which is A. So here we have 4 times 1 plus 10, 4 times 2 plus 10, 4 times 3 plus 10, and 4 times 4 plus 10. So I want you to pause, try to answer these, and then when you're done, hit play, and then I will give you the answers. So pause it. All right, so the answers for 1 game is $14, 2 games is 18, 3 is 22, and 4 is 26. All right, use the values on the table to draw a graph. And this is not going to be a perfect graph because I do not have graph paper here. 0, let's see, 1, 2, 3, 4 games. And then we will go by 2s. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, so my first ordered pair, I would look right here, is 1 and 14. So down here, I would go 1 And I would go up to 14 and draw a circle. My second ordered pair is 2 and 18, so I'd go to 2 and do my best on my not perfect graph. 3 is 3 and 22. And then 4 is 4 and 26. And we know if we have a straight line, and if this were on a perfect graph, it would be very straight. We know that we have the correct solution. All right, that is it for today. Do work on your iReady and Mathia.